The title of section 9.1 is Tangent Properties. In this section, we'll review terms associated with circles. We'll talk about the way the tangent and the radius are related, and then we'll discuss tangent segments from a single point outside a circle. So set this into your table of contents, 9.1 Tangent Properties, and then set up a fresh page and we'll get some notes. So let's start with a circle. The center point is called point O, and draw a tangent line. We say line M is tangent to circle O. The point at which they intersect, let's call that T, and it is a point of tangency. So our first conjecture, the tangent conjecture, says that the tangent line and a radius drawn through the point of tangency are perpendicular. So just a quick review, some other vocabulary with circles. We all know radius is the line segment from the center to a point on the circle. A chord is also a special line segment. It has endpoints on the circle. A secant is kind of like a chord. The difference is a secant is a line, not a line segment. And then here's our tangent line. Reminder, a tangent line intersects the circle in just one point, and that point is called the point of tangency. And we know AD and DE are perpendicular, or another way to put that, angle ADE is 90 degrees. So let's work an example using the tangent conjecture. Take a minute and sketch this in your notes. Circle A has a radius x, and B is a tangent point. Solve for x. The key thing to recognize is that we have a point of tangency. If B is a point of tangency, then angle ABC is a 90-degree angle. Also note that AB and AD are both x. And that's important because now we have a right triangle, ABC, where AC is x plus 8, and then we can use the good old Pythagorean theorem to solve for the unknown. So AB squared plus BC squared equals AC squared. Sub in the values that we know, and then doing the usual method, we'll solve for x. So subtract x squareds from both sides. I get that x is 5. Next conjecture is called the two segments conjecture. If two segments from the same exterior point are both tangent, then those two segments are congruent. Let's talk about why this is true. So let's say we're given circle O, and we have tangents TA and TN. It's our job to show that TA and TN are congruent to each other. So first, draw in the radii. Reminder that the radii through points of tangency form 90-degree angles. And then we're going to draw in a helpful auxiliary line, AN. Why is OA congruent to ON? The radii of the same circle. And so that means that triangle OAN is isosceles. What do we know about isosceles triangles? We know that base angles are congruent. So angles 1 and 2 are congruent. Well, we also know that angle OAT and ONT are 90-degree angles because they're at points of tangency. And so that means if 1 is equal to 2, then 90 minus 1 is equal to 90 minus 2. So we could say those are angles 3 and 4. Well, if 3 and 4 are congruent, then triangle ATN is isosceles. Well, and isosceles triangles have congruent legs. And so there we go. We've proven that TA and TN have to be congruent. Let's work a few examples. Here I've got two circles that are externally tangent, and I'm sorry about that smaller one. It's supposed to be a circle, and it looks awfully crummy. So do your best, sketch this into your notes, and let's say we have x and y labeled as such, We have 10, y minus 5, x plus 4, and y. Using the tangent segments conjecture, I know that y and 10 have to be congruent. Likewise, if you think about tangency from the big circle, I know that those two lengths, the two full lengths, should be equal. And if y is equal to 10, I know that the whole length there is 15. And so 15 and x plus 4 plus 10 have to be equal to each other. And so that means x is 1. Here's another example for you to sketch. Here we have a triangle that's inscribed in a circle inscribed in a triangle. And we have a few lengths given. The perimeter is 30, and we want to solve for x. So the key there is inscribed. If it's inscribed, that means it creates points of tangency. And using the tangent segments conjecture, I know that those two lengths would be 7. Likewise, those two lengths would be 5. And the unknown up top are both x. Given the fact that the perimeter is 30, I can add up all three sides. 5 plus 7 is the bottom, x plus 5 is on the left, and x plus 7 make 30. And then all that's left to do is to solve in the usual way. We get that x is 3. I have 2 more examples that I'd like you to copy down for your notes. Give them a try, and we'll talk about them later. Push pause and trace them into your notes.